Hello there. As I have received your request for the calculating of the masses, we're gonna use a regular program for the calculations. The most convenient one is gonna be the Excel, Microsoft Excel. To start, we have to draw the structure in the very convenient and really any available graphic editor. We have to select it and analyze it on the chemical formula. The chemical formula of ethylene oxide is known. It is C2H6O2. Subsequently, we will put this formula as a digits in the Excel file, and then we're gonna use it to calculate the total molecular weight. Let's call this cell as a molecular weight abbreviation. To find out the molecular weight, we're gonna use the regular calculation formula, and we are going to multiply the number of the carbons, which is B2. We're gonna multiply it on the atomic weight. To find out the atomic weight of each atom precisely, we have to Google so-called exact mass calculator, and if you're gonna just Google it, you're gonna find it really easily as a first or a second reference. So let us leave the just the carbon alone and find the find the exact mass. It's gonna be 12, right? So we're gonna copy the exact mass of the carbon, go to the Excel, and put into the equation. Also, we have to go and add the C3, the number of hydrogen atoms in the ethylene glycol is going to be C3 multiplied on the exact mass of the proton. The exact mass of the proton is going to be 1.007. It's not 1, but 1007. We're gonna copy it and paste it here, and also we have to add the mass. Oh, sorry, it's gonna be C2. And also we have to add the weight of the oxygen, and the number of oxygen items is D2 multiplied on the exact mass of the oxygen. The oxygen is 1599 somewhat. We copy it and paste it into the Excel. Now we press the enter and find exact mass of the ethylene glycol. Also, we know that any other ethylene we also know that the ethylene oxide polymers comprises of ethylene oxide units, and the difference between the ethylene oxide fractions is one ethylene oxide unit. So we are going to add ethylene oxide unit in this formula. Ethylene oxide comprises 2 carbons and if we add it to the ethylene glycol molecule, is going to be C4H10O3. C4H10O3. As you can see, the number of carbons has emerged on 2, and if we're going to select it and go further, it's going to happen gradually. The same thing is going to happen to the hydrogens, is +4, so any other ethylene oxide unit will make the molecule on 4 hydrogens heavier, and you can easily check it. And if any ethylene oxide unit is going to make the other molecule to one oxygen atom heavier. Subsequently, you drag the molecular weight of the ethylene glycol and get the exact masses of the ethylene oxide of polyethylene glycol molecules. Now, to get the protonated mass, because only protonated masses can be detected, you just have to add one proton to the exact molecule of the ethylene glycol or its derivative. So what you have to do is just to find the weight of the one proton, find the mass of the one proton, and add it to the one molecule. Thus, and this is how you find the protonated mass. And this is what is actually detected by the majority of the mass spectrometers. So what you have to do is just to type F2 plus and the atomic weight of the hydrogen. Enter. This is it. So ethylene glycol will be detected at 63.4461. Dragging these data is going to give you the protonated molecules of polyethylene glycols. Got it? Now next, you also asked me if the molecule can be detected as one with the molecule of water. Make sure that the molecule of water has been added to the protonated one, because otherwise it's not going to be detected. It should fly in the magnetic field and thus has to be protonated to be detected. And water, the exact mass of the water can be easily detected as H2O. It's 18.1. Control C, and this is how you get. You just add the water to the protonated one, and it's going to be G2 equals G2 plus weight of the mass of the water. Here we go. The protonated hydrate of the ethylene glycol will be detected as 81.5517. If you want, we are going to call it as protonated hydrate. Okay. If you wish to detect the sodiated, you have to put sodiated. You have to take the molecular weight, exact molecular weight, which is F2, and add the atomic weight of the sodium. Sodium is detected as, and the exact mass of the sodium atom is 2298. We copy it, we go to the Excel, we take the exact mass of 62, which is F2, plus enter. We drag it for each other macromonomer. If you want the sodiated hydrate, you take it as a sodiated hydrate. Hydrate. You take the J2 plus water, H2O. Control C. J2 plus water. And this is how the sodiated hydrate is going to be detected. And this is how you find the exact mass for the sodiated hydrate of the macromonomer containing 136 ethylene oxide units. It's gonna weigh as 6046. Got it? Same thing works for the protonated, sodiated, hydrated. Make sure that the hydrated stuff is not charged, and it's only going to be charged as you add the charged species as proton and the sodium. That's actually it. You also can copy it and export it to the any file that you want to use, either Word file or PDF. You just copy it, create a new file, page layouts, as orientation, landscape. Make sure everything has all borders for your convenience. Now we have the names. Treated, hydrated, protonated. Good luck with it. I hope you understand what I have told you.